All right. So as we continue on this AI 2030 discussion, there's been a lot of discussion around the success and failures of a lot of projects. So I want to address some of that before we get into even more of these metrics. So in this document about the insurance, we talk about AI layer with the human enhancement. And I think um, an efficiency reinvestment. So I really think these three here kind of explain where a lot of these projects go wrong. And there's been a lot of white papers and discussions about how to effectively use AI. So if we talk about some of those and how we address that, is that first of all, one of the issues is around data quality. So the data quality in insurance can be very variable. We can talk about conversation logs. We can talk about email threads, SMSs. We can talk about internal documentation. All these things are subject to a level of correctness and incorrectness. So they're not perfect, basically. And the AI is subject to confusion as an LLM, so like ChatGPT. If you feed it a lot of data, then this can be good. But if you feed a lot of data which is contradictory, which is maybe misaligned, which is irrelevant to a core subject matter, the AI will not be able to perform the way that you expect. It doesn't necessarily have a sense of what is more true between two statements. So if one statement is opposite to another statement, then it's not necessarily going to know what's true. Um, and and other reasons for project failure is that if you just chuck an LLM at a solution, you're generally going to fail as well, depending on what you're asking it to do. So the LLM is only as smart as what it knows generally. So if it's never been fed information about what it's trying to achieve, what it's trying to learn from, then it's just going to go what is the most general answer that it can provide possible. And obviously, other issues is that even when people do implement LLMs, they're heavily dependent on prompt engineering without feedback loop. So I think here we have a great example when we talk about human enhancement is that the AI knows what you give it, but it doesn't mean it's necessarily um, it doesn't necessarily know how to improve over time. So it's not a continual learning algorithm. Um, you can only continually learn by enhancing your knowledge base, by enhancing your FAQs, and by refining what is correct and what is not correct. And there's a variety of ways of handling this. So in this collection, these AI can get very intense. And something that is not known by many people is that LLMs also have confidence scores. So indicating whether it's very confident with what its action is versus what its action isn't. So this would be, if it's just making things up, it's going to have a low confidence score. If it feels very precise about it, then it's going to provide high confidence score. The other element here is using tooling. So tooling provides the ability for the AI to access data in a format that is structured. So think of LLMs as unstructured data. It's the ability to use unstructured data, but take advantage of your structured data, which can be achieved through API calls or internal knowledge bases or looking up templates and other aspects like that. So these are different ways that will will reduce your LLMs from failing. Another aspect is last time I talked about treating your your overall LLMs or your AI as an agent. And in the agent, I talk about all these aspects from the environment of the agent, the state, so what it's trying to achieve, a reward system, policy, basically how to maybe predict what the results are and probabilities of results. Won't get into value functions, and the model is similar. So with this, something that can be done with metrics is metrics can be seen as the objective of your AI. So an example, how to respond to someone, how to answer something. You may have an objective. So the objective makes the AI, instead of instructional, objective driven, and then combining those objectives with data. So there's ways of doing it. So LLMs are good at unstructured data, at formatting data into a certain structure, and really being the heuristic. So being able to analyze research data, information, and creating assumptions about how something should work. Something that we enhance that should be done when you're building out your AI is combining your standard LLMs, um, understanding your reward system, so what KPIs your LLM is going to achieve, and then having an infrastructure. So, an example in infrastructure is that providing LLMs, or let's call them agents, a advisor. So something I that one way to minimize errors is when you come into numerical data and you think about A/B testing an ad, A/B testing information, you can do the same with the LLM. So if you're predicting a tonality, a time to wait for a response, a how much a percentage office should be, and this is kind of a decision that needs to be made, and you can know what your KPIs, i.e., what is a good result, what is a bad result, you can now create advisors for your LLM. So an advisor would be something like reinforcement learning or a neural net, which is able to look at uh, continuous or discrete actions and actually use a neural net or something similar to actually calculate the achievable results. So having an advisor means that your LLM's not going to necessarily learn how to optimize numerical values in a reward system, but an advisor can. So implementing advisors massively improve it, and uh, massively improve when you're getting into numerical values and actionable decisions. And you can see that from deep research and other kind of programs which are using this technology. The second thing is by providing different reward systems in here and different guards. So providing critical actors and guards. So when we look at research with you know, deep thought or deep research, they're never just standalone agents. The agents are performing a sequence of actions. So you have a core action, a core orchestration agent, which has got, we understand the rewards. It's performing activities such as research or pulling back knowledge or executing APIs to feedback information, and then it's making a decision from its own information, advisors, if you have advisors, and then makes an action. That action is then can go through a review process. So a critical actor, a critical reviewer will be able to say, is this actually a true result or not? And that's when you talk about routing to different elements to humans. You need to escalate to a human to get the real result because the AI layer or the agentic layer doesn't have enough information. Or do you pass through and log it as an error that needs to be looked at in the future? And these things kind of happen. Uh, a second layer of that critical reviewer is called a guard. So those guards, on the other hand, stop garbage or insensitive or just lying information to get passed through a process. So, for example, if you're trying to write an email and it's saying you get 100% discount, um, then your critical actor might fail, but your guard will say, this is impossible. Don't send it. It's a not logical within the criteria of what it should be. And each of those can have their own knowledge base and access to information to improve it. So going back to this, so when we talk about this, the failure of a lot of these implementation is because we don't have a structure, because we don't understand the environment, because we're trying to get the LLM to possibly do too much. We don't understand what is good, what is bad. Uh, we're allowing information to flow through without some type of guards and critical actors or reviewers, and we're missing those core elements. So putting all those elements together means that our AI layer is interacting on its own to optimize. It's interacting with human enhancement when it needs to either escalate or provide QA or refine ambiguous knowledge. And then obviously here we can implement it. So when we talk about improvement and things like that, then we can start seeing other aspects of how to make decisions, like what more information do we need to make decisions in our AI layer, or what are the different actions that we could possibly occur. So these are kind of the items which we need to factor in to avoid failure in the process. So it's just a quick video because it was brought up, and I just wanted to summarize some of those aspects. All right, thank you, and catch you in the next video.